Hello fellow Scratchers, I'm Griffpatch and welcome back to part 9 of our series creating a tiled scrolling platformer in Scratch. Today we're continuing to look at enemies, adding them to the level editor, and we'll also discover how enemies should behave off-screen. Finally, we'll finish off with the enemies saving and loading. Let me take a moment to remind you that it might be a good idea to back up your projects before we start work. I always do this before each episode, saving my project as a copy. Also, in case it helps, I've provided a link under the video to the completed project for episode 6. If you need to compare your scripts or want to remix from there, then well, you know where to find it. Now, before we dive into creating our exciting new features, we have 2 bugs spotted by followers of this channel that we should address. I can easily show you the first. When I spawn Goomba on top of this blue drop-through platform and then press the down key, all the Goombas drop down through the platforms too. Really quite a funny mechanic, but not the desired behaviour. This is occurring because we copied all the collision detection scripts from Mario into the enemy sprite without alteration. In the enemy sprite, find the define fix collisions at point XY script. This if check here is to blame. See, it's looking for the down key presses. We simply remove this and now testing again. Yep, that's sorted it. The next bug is a little bit more subtle. When we bounce on a Goomba's head, we tend to be overlapping quite a lot more than expected. Well, this is true, and it's because in the define tick Goomba block, we are performing a touching here, before we have moved the actual sprites on the screen, which means we are testing last frame's collisions, not this frame's collisions. We can add in a paint sprite here to reposition the Goomba, but more importantly, click into the Mario sprite, and at the end of the when I receive move player script, since Mario is jumping and will therefore be moving fast, we again add a paint sprite for Mario too. Now, let's test that and see if it looks any different. Ha! Well, not a huge amount to the untrained eye, but compare it again in slow-mo, and yes, the new bounce is much less overlapped. That's how it should be. Okay, so back to today's tutorial. Click into the enemy sprite. We need to make the Goomba costume available in the level editor. So drag the first Goomba costume over to the tiled sprite. Now, if we look at the tile costumes, we can see it has appeared as costume number 29. We'd better remember that number, 29, got it? Now, we need to choose what key in the editor swaps to the Goomba brush. Click into the editor sprite and make the tile keymap list visible. We'll add a new row for costume 29, the Goomba costume, and assign a key press of 9. Now this is a new key, so to make that work we need to duplicate one of these, when key pressed blocks, and configure it for the key 9. Also setting next brush to 9 too. This is a testable moment, so run the project. Press 0 to enter the level editor, and then number 9 to switch to the Goomba brush. I can lay a few down on the level, exit the editor, and there they sit as standard tiles on the level. But not all is well with this solution. Remember those semi-solid platform tiles over here, the blue ones? What if I want to place Goombas in front of these? Oh dear. As soon as I do, Goomba replaces the decorative background tile, making things look bad. Is this a disaster? Well, yes and no. The majority of games I code also do not allow enemies to be spawned on top of other tiles. Think Apple. It's just part of the level design. However, for Mario, it's not so easy to get away with, as these situations come up a lot. I asked you guys whether you were up for the challenge of allowing placement of enemies on top of tiles. And the overwhelming response was, oh boy yes. So, I hope you are ready for this. I'll just go back over my level and remove the Goomba tiles. Okay, so our actual Goomba spawning code is still in the enemy sprite and is triggering off the G key, positioning Goomba at Mario's feet. But no matter how we proceed to spawn our Goombas, this will need to change to allow the positioning of them at a given tile location. If you click into the Mario sprite and find the define reset player script, you can see we are doing just that here for the Mario spawn, setting their X and Y variables based on a spawn index variable. We'll reuse these 4 blocks. To do that, I'll just duplicate the whole lot and then remove the parts we don't need. There, this is all that's required, so drag them onto the enemy sprite, like so. Click into the enemy sprite and drag the new script over to around the existing when G key pressed and when I start as clone blocks. We're going to rearrange these three sets of scripts now. We'll start by making a new custom block for spawning enemies, naming it spawn type, with a numeric input of tile type, run without screen refresh. So I'll put the set X and Y blocks we just brought over from Mario into the custom block to position them based on their spawn index. Then I will set frame to the empty value to indicate that the enemy has just been cloned and is yet to be drawn. Now here's something new. We add an if tile type equals 29. Yes, it's the Goomba tile again. So if we are spawning a Goomba, then we can do everything we used to do when a new clone was created. Drag those scripts over from there. But make sure to remove these old set X and Y blocks to prevent the spawn at Mario's feet again. Next we need to take the create clone of myself block from the when G key pressed and add it after the show block here. Finally, at the very end of our scripts, after the cloning is done, we set type back to the empty value and we hide. This is to keep the identity of the original sprite. Only the clones should be left with a type variable set. Okay, it would be nice to test these scripts. To do so, we'll need to just invent a way of triggering the spawn block, so let's reuse the when G key pressed hat block. This, when I start as a clone block, can be deleted. We'll set the spawn index to tile index of editor. This reflects the position of the mouse on the level when the level editor is in use. We can then spawn type of 29 and that will spawn a Goomba. Great, now we can happily test this. Click the green flag and press the 0 to enter the level editor. Then press 9 to switch to the Goomba tile, but then, for the time being, press the G key to run our test script and spawn Goombas at the mouse cursor. Yay, this is great! The Goomba is no longer appearing at Mario's feet, but instead at the mouse cursor. Excellent. Our next hurdle is to liberate Goomba from the G key altogether. However, we are not going to be able to store them in the tile grid list, because this doesn't support placement of enemies over existing tiles. So, we will instead store the enemies in new lists of their own. Before we create the lists, we need to add scripts to clear away all these Goombas. Bring in a when I receive level done loading. That's the perfect place to trigger a clear down and respawn of enemies, as it's broadcast right after a level is loaded. What we'll add in here are two new broadcasts. Set the first one to the new event named Entity Clear, and the second to Entity Setup. You can probably guess what these are going to do. When I receive Entity Clear, just delete this clone, simple as it gets. All the enemy clones will disappear. Then, when I receive Entity Setup, this is going to have to run quickly, so create a new custom block naming it Spawn Loop, and we run without screen refresh. And then, drop the new block under the Entity Setup receiver. Now this is a good point to create those new lists to hold the enemy spawn information. Create two new lists, Object IDX, that is Object Index, for all sprites, and Object Type, also for all sprites. Now I call them objects rather than enemies, as I expect we'll end up storing more than just enemies in them. Okay, so here is an example of how the lists might hold the position and type of 5 enemies. We simply have pairs of data. On the left, the tile indexes, where the enemy spawns on the level, and on the right we have the tile type. So, at level index 447, we're placing a Goomba, that is tile 29. And then at index level 682, we have another Goomba. Simple. Okay, back to the code. We're going to need to loop through the list, so make a new variable named objectItem_hash to keep track of which one we're looking at. Now let me quickly dash through creating this script and I'll explain it to you afterwards. Okay, here we go. We start with object item 1, As we enter this repeat loop, we begin by setting the spawn index to row 1 of the object index list. That's where we want the enemy to spawn. And we set the spawn type from the object type list. Then our spawn type custom block takes these two values and does the hard work of setting up and cloning our enemy. After the spawn is completed, we hide this main sprite, not the new clone mind, and then change object item hash by 1. This takes us on to the next enemy row and the spawn loop continues. Once for every item in the object list. Finally, after creating the clones, to ensure this sprite does not get mistaken for a clone itself, we set object item hash and the type variables to the empty value. Well, that's the spawning scripts out of the way. Now we need to get the enemy data into these lists via the level editor. Click into the editor sprite and find the when I receive move player script. This is where all our level editing scripts live, and this, if brush equals 0, will run when the mouse is pressed down in the editor, ready to draw. We're going to insert a new if condition in here that differentiates between tile drawing and enemy placement. We can identify these by their key mappings. So key number 9 is for enemies. Make a new custom block, naming it Paint Enemy. Run without screen refresh, which we'll use right away within this new if. Follow it up with a stop this script to prevent it continuing into the tile painting code. Now, I'll just move the define Paint Enemy block into some free space and we can code it up. Firstly, unlike painting tiles, we only want to allow dropping of enemies on the first mouse button press, not during a drag. We do this by ensuring we set brush to a value as soon as something is painted, and then stopping this script from running again until brush is set back to 0. This happens when we let go of the mouse. Next we look to see whether there already exists an enemy at the tile index we are clicking on. Going back to our example lists, we could ask, is there an enemy at tile 682? And in Scratch this is done using the item hash of list block. So, item hash of 682 in object index would return the value 2. This is great because we can use this to allow us to place and remove enemies in the list. So we set found index to item hash of tile index, that's where we're drawing to, in the list object index, and then compare whether found index is greater than 0. If it is, then an enemy already exists at this tile and we remove it by deleting the enemy at item found index of both object index and object type. But if an enemy was not found at the tile index, then we instead register a new enemy by adding the tile index to object index and adding brush to object type. Finally, we finish off the scripts by forcing a redraw of the enemy sprites by broadcasting entity clear and then entity setup. It's just easier to delete and recreate all the enemy clones than trying to handle which one to remove, create or update. Okay, let's test this and see what happens. Pressing 0 to enter the level editor and then 9 to switch to the Goomba brush, I can click and hopefully place one. Woo, it worked! Only he's walking off. I was half expecting him to stand still, but figures, we haven't yet coded enemies to do that. Notice how every time I change the enemies on the level, the Goombas are all resetting to their start positions. That's a good sign, exactly as expected. Now let's stop the enemies from moving when in editor mode. Click into the enemy sprite and find the when I receive move enemy receiver. We'll add a new if at the very top and check whether editor is greater than 0. That is, we are in the editor mode. But we'll also check whether type is equal to the empty value, and then stop the script. So no sprite movement is run when in editor mode, and the type check is just to ensure that only clone sprites run these scripts. We can now test again, and yes, the enemies we placed a moment ago are now stationary in the level editor. That's a relief. If I unpause with the 0 key, the Goombas spring to life, and as soon as I press the 0 key again, they all return to their starting positions. That's wonderful. But let's think for a moment about how enemies move. If enemies who are off-screen begin moving as soon as the level starts, then many will walk off the platform edges, fall down gaps, and once we finally reach them, will be in very unpredictable positions. This problem is generally solved in platformers by placing the enemies in an idle state, in which they simply hold their position until, that is, the player approaches and they scroll into view. We can script this effect in the WhenIReceiveMoveEnemy script. Start by moving the ifType equals squish block above the ifType equals Goomba. The squish animation is not concerned with being idle. And then add an if above Goomba's if and check for a frame being less than 0. If you can remember, when an enemy is first cloned, we set frame to the blank value. We will use this to represent the idle state. It is worth noting that the blank value is counted as being less than 0. Now, if the enemy is idle, then we'll check if they're off screen or not. Check if the absolute value, abs, of x minus camera x is greater than 260. Since the screen width is plus or minus 240 pixels wide, that would mean that the Goomba is at least 20 pixels past the left or right edge of the screen. So we stop this script. They remain idle off the screen. We can duplicate this script and change it to look for y minus camera y being greater than 200. Again, that's 20 pixels further than the vertical extent of the screen. So, if we got this far, then Goomba is idle, but we're about to come on screen, so we should probably think about what direction we should walk in. If Mario is approaching from the left, then Goomba's x variable will be greater than Mario's x variable. So, we point Goomba left, that's minus 90. Otherwise, Mario is to the right of Goomba, and we point Goomba to the right, plus 90. There's nothing more to it than that, so let's run the project and test it out. The first thing we notice is that the top Goomba is the only one we are seeing. We know that there's another Goomba sitting just off screen to the right that I placed down earlier, but they have not yet made an appearance, so we can safely assume that they are idle. Let's just check. Yep, there he is. He triggered as soon as we approached. I can test this further by placing down some Goombas on the blue platforms to the far right. Now if I come back here and start the level up again, then all the Goombas stay idle on the platform until I come across them. Like so. Brilliant! The idle state is working perfectly. Very good. And that only leaves us with one more item on our to-do list for this episode, adding the enemies to the save codes. Well then, click with me into the level store sprite. Before adding yet more scripts, let's break up these long save and load scripts into smaller parts to keep track of what is happening. We'll start by making a new custom block named Save Tile Grid. And we'll move the scripts that are solely for writing out the tile grid list into here. This part is just setting up the save, so skip that, and we'll take this part, where we write out the width and height of the tile grid, and everything below. However, if we look down at the bottom of this script, the very last part, the final repeat loop, is what we do to put the save code into the level store. So bring that back up here. Just remember to pop in a call to save tile grid just before we attach the repeat script on the end. There, that's clearer to understand. See, we prepare the save code, add tile grid to save code, and store the save code. Next, we'll do the same for the loading of levels. Create a new custom block named Load Tile Grid. And move the delete all from tile grid, and everything following it, into the new define block. Again, replacing the original scripts with a call to the new Load Tile Grid block. We need to make a small change to this Load Tile Grid script before we will be able to extend our saving. The repeat loop in here currently only finishes when the entire save code has been read in. But if we are adding extra data to the save code, we need to stop this loop instead when the full grid has been read in. So within this final if condition, add a new if to check when tile index is greater than grid height. Now because we transposed our level before saving, each time we have read in a complete row, we move up to the next column. This if is watching for when we've moved up the full height of the level, and so we stop this script. And so we break out of the repeat loop. Okay, we are ready to actually extend these scripts now. We are simply going to add a second data block to our save code. The first was the tile grid list, the second will be the object lists. Starting with the saving script, we'll add a new custom block named Save objects. Drag it in right after the saving the tile grid like so. I'll move the define block into some free space. We'll need a new variable named row for this sprite only, and then let me build up this save script quickly. Basically, we start by recording the number of enemies in our level, and then starting at row 1 we write out the enemy's position, that is the tile index, and then their type, both using an underscore delimiter. No cunning compression here. Then, it's a simple matter of changing row by 1 and repeating for the next enemy in the list. Loading them back is equally straightforward. Make a new custom block named load objects. Pop it under the load tile grid. It's important we read data out of the save code in the same order we put it in. Then take the define block into some space. Let me quickly code this one up too. So, to load the objects, that is enemies, we first delete all of the items from object index and object type for a fresh start. Then read value. This will give us the number of enemies to be loaded, storing it in the value variable. We use this in a repeat block, so that it will loop around once for each enemy saved. Start by reading another value. This will be the first enemy's level index. Add that value to object index, and then read value again to get the enemy's type. So, add that to object type. The loop then repeats and reads in the next object until the entire object list are fully recreated. Well, in theory, assuming we didn't make any mistakes, then that should be it. We can run the project and see whether it works. First thing to note is that all the Goombas I have placed earlier have gone. Well, that makes sense because they were not saved in our save code at the time. And our level loading codes now cleared them down before loading the level. Well then, I'll enter the level editor, press 9 and place some Goombas down. Then when I exit the editor, the enemies should have been added to the level save code and stored. I'll just squish him to remove him from the level and then re-enter the level editor. Now this is good sign. Goomba has reappeared. That pretty much proves our save and loading scripts have worked. But an even better test is for us to switch to the second level, level 2, using the L key. And look, no Goombas are here yet. I'll place a couple on this first platform here. Good. Then, if I switch back to the first level, there, just one Goomba was left. That's really perfect. Now we can have fun populating our level with many, many Goombas. And that sadly brings us to the end of another episode, but I'm super happy that we went to the trouble of allowing enemies to be placed over other tiles. That's a really awesome feature that will have further advantages moving forward. I can't wait to reveal those to you in upcoming episodes, but as a clue, mystery boxes. I can't believe we're almost at episode 10 already, and we haven't yet covered Mario losing a life. We really need to get that done. Do keep me up to date with how your projects are coming along. If you've enjoyed this tutorial, then smash that like button and don't forget to subscribe to the channel to avoid missing my next exciting video. Thanks for watching and scratch on, guys.